everybody and welcome to my YouTube channel. I'm Michael. I recently posted some videos about improving my workspace, organizing my workshop, improving my machines, building tools, etc. And I thought it's about time to show that I can actually build something with all these machines. This video is about a toy I designed for my grandson. It's actually two toys in one. It's a puzzle and a maze. And the majority of the work will be done on my CNC mill. It's a Tormach 770M, but we're also going to build some smaller parts on the lathe and on my Snapmaker laser cutter. First, I would like to take you to my computer, show you the design in a 3D Fusion model, also run you through the CAM, or how Fusion calls it, manufacturing process. And then we come back to the workshop and actually build this toy. In addition to that, this is a pure hobby workshop. I'm not running a business out of it and I'm not sponsored by anybody. Okay, here's a 3D Fusion model of the toy. The base block is made out of antique hard pine, 8 by 4.5 inches, 1.5 inches thick. The surface of the block has 5 pockets with 5 letters which form his name. And we're going to mill those pockets on the CNC mill. Each letter has a little aluminum pin, which we're going to create on the lathe. These pins make it much easier to take the letters in and out. And one comment regarding the DXF file for the laser cutter, I projected the letters onto a sketch pane and then used the offset command to make them a little bit smaller. I used a 0.5 millimeter offset. And I treated them differently. The outside geometry I moved inside 0.5 millimeter, and the inside geometry I moved outside. You cannot use the scale command here. The scale command would work for E, Y, and N. It would not work for A and D for one reason. Scale reduces the complete geometry. That means the outside geometry and the inside geometry get smaller. So if this inside geometry gets smaller, it will not fit into this geometry in the wooden block. So you need to treat this one differently from that one. This one needs to move inside, this one needs to move outside. And then I had this geometry, and then I just exported this as a DXF file and sent it to the laser cutter. This is the opposite side of the wooden block. It features a maze for these two steel balls. One is polished and one is black. And the goal is to exchange the position of both balls. Each ball has a little resting place here. These channels for the maze are going to be milled out with the CNC mill. It has a pocket here for an acrylic cover, because the little man has a tendency to swallow these balls, and in order to prevent him from doing that, just covered with an acrylic sheet so the balls cannot come out. And now to the manufacturing part. The first setup is for the top side, the side with the letters. We're not going to machine the outside of the part. It has finished surfaces already. We are going to face it off. Then we do a 2D adaptive strategy for the pockets. We then run a 2D contour to give the pockets a nicer surface finish. And at last, a 2D chamfer for the outside corners and for the letters. I left the parameters pretty much where they were for my aluminum cutting tools, with 2 exceptions. First, I run the cutters at 9,500 RPMs, and I go full depth of cut. This is a 6 millimeter deep pocket. You could not do that in aluminum. Actually, you could try. You might not get the results you were hoping for. So full depth of cut. You might have noticed I calculated a step over for the facing operation in a way that the cutter always cuts inside the wooden block. If you would run here on this side an outside cut, you would create splinters. So let's run a simulation. Here we go. First is the facing operation. It's a 3/4 of an inch shear hawk. Next one is the 2D adaptive with a 1/4 inch end mail, no corner radius, full cut, full depth of cut. And speed that up a little bit. And then you see the little line here. That's the 0.5. Here we go. The 0.5 millimeters are left at the 2D adaptive to clean it up with the 2D contour. And finally, that was the chamfering for all the letters in the outside. So here you have it. The second setup is for the bottom side of the wooden block, then the side with the mace. We start with a facing operation, then a 2D adaptive to carve out the first pocket, which later holds the acrylic sheet, a 2D contour to clean up these surfaces here, then a 2D adaptive for the channels of the mace, then a 2D contour for the channels of the mace. I left 0.5 millimeter stock to do that. Then a quick drilling operation, 3 millimeters deep for the ball rests, and finally chamfering of the outside of the block and all channels and the resting places. This is a simulation. Here we go. Again, 3/4 of an inch shear hawk. Now first is the 2D adaptive for the first pocket. Speed that up a little bit. This now is the 2D contour, and now we go to the 2D adaptive for the channels. Speed that up a little bit. Again, I left 0.5 millimeter stock for this operation now. That's a 2D contour. And now we have a very quick drilling operation, just 3 millimeters deep here for the ball rest down here. We use a 1/4 of an inch end mill for that. And then finally chamfering the outside and then all the letters. Can speed that up a little bit. And here you have it. Here you see the work process for building this toy. First on the miter saw we cut the antique hard pine stock to dimensions. Then again on the miter saw we cut the 6 millimeter thick acrylic cover plate. We round the edges of that plate and we drill 4 holes in the corners of that plate. On the CNC mill, first we mill the top side for the letters, then the bottom side for the channels for the mace and the ball rests. On the laser cutter, we cut 5 letters out of 3 millimeter acrylic sheet. On the lathe then, we turn the aluminum letter pins from 5/16 round rod. Then we spray paint the letters, press the aluminum pins into the acrylic letters. Then we blacken one steel ball. We polish the wood with natural oil finish. With a cordless drill, we mount the acrylic cover plate. And then the last step is to attach 4 rubber or felt pads to the corners of the top and bottom side. So work holding. The vise opens up with a jaw installed about 4 inches. My stock is 4.5 inches, so I took off the jaws and put in 2 half-inch parallels, and now the workpiece fits nicely. Gave it a little tap, make sure that the parallels don't move, and then clamp it down. And now we are going to set the work origin on this corner. First I use the passive probe, and when we flip the part over to do the backside, I use my Heimer to show you different options to do that. And if you would make more than one part, you would probably use one of these guys. That gives you a pretty repetitive location of the part. But since we only make one, and when we flip it over, I need to indicate the top anyway, so it's not worth the effort in this case. Okay, now the probing routine starts. So that's indicating the X and Y direction. Now we go to Z. Good. So we indicated this corner in X, Y, and Z. And now we can start with milling. And I put in the first tool. What I do before I start the cycle for the first cut, I reduce the feed rate to about 20% or something, and also the maximum velocity to 20%, just to be on the safe side. And when I see that everything goes according to plan, then I ramp them up to the 100%. Just a safety measure, risk management, so to speak. First operation is facing off the top, and I use the shear hawk for that. Okay, that looks good. So I put up the feet to 100% now, and the max velocity too. I set the tool path that is always cutting inside from the edges, that I don't get any splinters here. So next tool is a 1/4 inch end mill. This is a 2D adaptive layering operation. Put on some air. That is a 2D contour to finish the edges. The 2D adaptive is not a finishing operation. That's why I use the 2D contour. Okay, and the last operation for this side is chamfering. For which we don't need air, so I turn that off. Use a 1/4-inch chamfering mill for that. And that is it for the top side. Now we're going to flip the part over, indicate it, and then mill the second side. For the next operation, I changed the camera position, might be easier for you to see. Next step is indicating again the left top corner of the workpiece, and this time I use a Heimer. The first time I used the passive probe. If you're not familiar with a Heimer, it's a German-made, super precise and fun to use tool, super fast, and show you how it works. Just move the tip of the probe against the workpiece until both indicators read 0. Here we go. That's your X0. Move it back. Go around the corner. Do the same thing for Y. Here we go. That's your Y0. And now move it back. Now we do the same thing for Z. And here we go for Z. As I said, we're talking about wood here. It doesn't have to be super precise. The Heimer is probably a little bit even too much for that, but okay. And let's go back to T0. Okay, so we indicated the left back corner of the workpiece as work origin for the next steps. Okay, now we start milling the bottom side. Again, we start with a facing operation and to set the feed rate to 20% for the first cut, just to be on the safe side. Here we go. Back to 100%. Again, I choose a tool path that the cutter always cuts inside the workpiece, that I don't have any splinters here. Next operation is 2D adaptive with 1/2 inch end mill. Just turn on the air to clean the wood chips out of the pocket. next operation is a 2D contour, and I use a 1/4 inch end mill for one reason. The 1/2 inch end mill I had has a 0.03 inch corner radius. I want an end mill without a corner radius because in here later on goes a acrylic sheet, and I want to sit it on the bottom. With a corner radius it wouldn't sit on the bottom, and I don't have a 1/2 inch end mill without corner radius. I use the same tool for the next operation, so this does not cause an additional tool change. Now we start cleaning out the channels for the maze. These channels are 10 millimeters deep, that's about 3/8 of an inch. You couldn't do that in aluminum, but if you take a full depth cut in wood, it should be okay. This is again a 2D contour. The 2D adaptive is not a finish operation. And that's a 2D contour just to give it a nicer surface. I left 0.5 millimeter stock in the 2D adaptive for the thinning operation. This operation now cuts two little pockets, 3 millimeters deep, as the ball rest. So next and final operation for this site is the chamfer. It's again a 1/4 inch chamfer mill. 9,500 RPM. Chamfer width is 1 millimeter, And the tip offset is 1 millimeter as well. Now it chamfers the little ball rest on there. And that's about it. Turned out rather nice. Okay, we're at the lathe now to turn the little pins for the letters, and they're going to be the following operations. First we face it off, then there are 3 different diameters. The first one is the only critical measurement. It's 5 millimeters diameter for press pass into the acrylic letters. The second one is a 6 millimeter diameter to give the press pass a shoulder, and the rest is just to clean up the surface, and then we cut off the part. I need to take very light passes here because the material sticks out pretty far and I'm concerned about wobbling. So just take light passes and we should be fine. Measurement. Okay, this 10 over. Perfect. Good. The next one is just clean it. Before I come any deeper, I chamfer it. Here you have it. Moving on to cutting the letters on my Snapmaker machine. On the right side is the touchscreen with the user interface. We select the data file. Let's make an E. First step is the machine will measure the material thickness. Measured it as 3.04 millimeters. Next step is that you set your work origin. That means the starting point of the laser cut, which is for me pretty much the center of the letter. I mark the center roughly with a pencil mark here, sorry, here, here, set that as origin, and here we go. It's a 10-watt laser. Cutting speed is 100 millimeters per minute. And your noise you hear in the background is A, the fan for the laser module, and B, the fan for my air purifier, which I installed to get rid of the fumes. You notice the interrupted cuts. Normally the laser cutter would cut a letter with one smooth movement without interrupting the cut, but I exported these letters from Fusion as DXF file, and Fusion creates letters based on fonts in separate segments. So the laser cutter cuts each segment separately. The end result is exactly the same. It's just not one smooth operation, it's cut in separate segments. And here you have it. It's the letter E. Okay, we're at the bench press to press these pins now in the cutout letters. Put a drop of super glue on here. Here we go. And then we just press that in. Here we go. So here are all the parts: the wooden block, the acrylic cover, the 5 letters with their pins, 2 steel balls, 3.8-inch diameter, 4 stainless steel wood screws, and 8 rubber pads. And here it is fully assembled. That's the side, the top side with the letters. And that's the bottom with the mace. That's about it. Thank you for your attention. Some of you might say that it's a little bit over the top and over engineered for a little toy, and you're absolutely right. But you might have guessed it, I'm German, and that's just what we do. Also, it gives me great pleasure to give my grandson the opportunity to have a lively discussion about the advantages of a 2D strategy toolpath for a CNC mill. Probably forgot to mention that he's 18 months old and speaks 5 words. All right, thanks again for your attention, and I'm very much looking forward to see you soon.